Alright, so now we're going to talk about how do you calculate slack. So we're going to refer first to this network diagram that we created in class. For those of you who don't recall, we did a case in class called Fantasy Products. It's on page 664 of your text, and one of the things you needed to do was to develop a network diagram for that process. And boom, this is what it looks like. You will also recall that the critical path was this path here, A, B, C, G, and M. So that is the critical path, and the critical path is that path of steps, of processes, wherein any delay of any process on that path will delay the entire project. So you can have delays in these steps here without delaying the entire project, but any delay on any of these steps here, that's going to cause you to delay the project, and you're going to need to talk to your boss about why exactly that is. So what you want to know how long can I actually delay these steps here, because you can't delay them forever. Even though D, E, and F is not on the critical path, there's a limit to how long you can delay those steps before you start blowing your timelines. And in order to figure that out, that's where the tools of calculating slack come into play. So that's what we're going to do. We're going to calculate slack. So why do we care about slack? Slack tells you how many days or how long can you delay a step or a process without compromising the overall timelines of your project. Now, in order to calculate slack, there's actually four things we need to calculate. We need to calculate the earliest start time, the earliest finish time, the latest start time, and the latest finish time for every step of the process. Now, with these network diagrams, the system that we tend to use is that in the upper left hand corner we write down what the earliest start time is. That is how early, what is the earliest that we can start this project within the framework of our entire project. The earliest finish time is what is the earliest date that particular step can be finished, and we put that in the upper right hand corner. Now, by convention, the very first steps in the process, so here the very first steps are A, D, and H. By convention, the very first steps start at day 0. They start at the start date. So the earliest start time that these first steps can start on is day 0. So we set day 0 as the earliest start time for A. 0 plus the duration, which is 3 days, gives you your earliest finish time. So the earliest start time is day 0. It takes 3 days to finish, so the earliest day that process A can be finished is 3 days. Now, A and B have a precedence relationship. B cannot start before A is finished. So if the earliest A can finish is 3 days, then the earliest B can start is 3 days. So the earliest start time for B is 3 days, plus the 8 days that it actually takes to finish step B gives you an earliest finish time of 11 days. And so on. We do this through all the steps in our network diagram. But we have an angry red dot here. Something special is going on. We need to figure out what it is. That something special that's going on is process G needs 2 processes to be completed before it can start. Both C and F need to be finished before we can even start G. Now, the earliest finish time for C is 15 days. So if we start G at 15 days, well, we need to also have component F, and we don't know when component F, we don't know when its earliest finish days are going to be. So we need to figure out what's the earliest start time, what's the earliest finish time for all these processes here. So boom, we go ahead and we calculate that, and we find out that the earliest finish date for step F is 9 days. So if we use 9 days, this is the earliest finish time for F. If we set 9 days as the earliest start time for G, well, that doesn't work because G also needs item C to be finished, and item C is not going to be finished until 15 days. So here we need both C and F. F will be available after 9 days, but we're going to have to wait till day 15 before we have the second component C. Therefore, the earliest start time here is 15 days. And from from there on in, it's just like we've normally done. 15 plus 6 days duration gives us an earliest finish time of 21 days, and so on. We do that throughout the whole process here. But we have another little angry red dot here. This is where we start. We've finished calculating all of our earliest start time and earliest finish time. Now we need to start figuring out what is our latest start time and our latest finish time. And we start at the end here. By definition, we set the latest finish time of the very last step to be the exact same as the earliest finish time of the last step. So that's just what we do. So the latest finish time here, which we put in the bottom right hand corner, is going to be 22 days. And then we start to work backwards. 22 days minus a 1 day duration means the latest that step M can start is 21 days. And then we just repeat that process all the way back throughout the network diagram. So here, the latest start time is 22 days minus 1 day duration means the latest finish time is 21 days. Because this, the latest that it can start is 21 days, it means that the latest that the preceding step can finish is 21 days. So 21 days minus 6 days gives you 15 days, and we just work that back throughout the network diagram. But you'll notice we have a couple of angry red dots here, which means something special is going on with H. Okay, so H feeds into two separate processes. You need H to do step I, and you need H to do step J. Now the latest start time for step I is 11 days. That means that you must start process I by 11 days, otherwise you will delay the entire process. Step J has a latest start time of 8 days. If it is delayed any longer than 8 days, then you will derail the timelines for the entire project. So if this is the latest start time for I and this is the latest start time for J, what's the latest that H can finish? Well, if we set H, the latest finish date, at 11 days, well, process I is going to be fine. However, if H, the latest finish time, is 11 days, we're going to screw over step J. Step J must start no later than 8 days, otherwise you're going to delay the entire project. Therefore, we must set the latest finish time for H at 8 days. And what do you know? Here we go. The latest finish time for H is 8 days, so it finishes at 8 days, which is the latest start time here. You have a couple of days that you can, I guess, slack off here before you need to start step I. Alright, so now we've calculated the earliest start time, the latest start time, the earliest finish time, and the latest finish time for every step in the process. Hooray! Pat yourself on the back. Now, we're going to use this information to calculate slack. There's two ways we can calculate slack. One is you can take the latest start time and minus the earliest start time, or you can take the latest finish time and subtract the earliest finish time. Either way will give you the exact same answer. Let's have a look at step F. Now, step F, if we take the latest start time minus the earliest start time, that's 10 minus 4, that gives you a slack of 6. Likewise, we can look at the latest finish time minus the earliest finish time, 15 minus 9. Again, that is 6. So you've calculated the slack for step F is 6. Now, you got to stop and you got to ask yourself, so what? Yay, you figured out that the slack for step F is 6. What on earth does that mean? What have you done? Well, what it means is this. You can delay step F by 6 days without compromising the overall timeline of your whole project. If step F is delayed more than 6 days, now you're starting to impact your timelines. So if you delay F 1 day, 2 day, 3 day, 4 day, 5 days, 6 days, you're fine, your timelines are maintained. But if you delay any longer than 6 days, you're screwed. You need to talk to your boss and tell him why your project is falling behind schedule. Now you remember we had this process, this concept of the critical path. The critical path is a path path of processes where any delay will cause a delay in your overall project. And you'll remember that A, B, C, G, and M were on your critical path in this particular example. And if you calculate the slack, let's look at step C. If you calculate the slack, latest start time of 11 days minus the earliest start time of 11 days is 0. There is 0 slack in step C. Any delay in step C means that you would delay your entire project. So if a step has 0 slack, it is therefore on the critical path. Okay? So, just to review, you calculate slack by figuring out what the earliest start time, the earliest finish time, the latest start time, and the latest finish time is for every step in your process. You then calculate slack using one of these equations here, and slack tells you how many days or how much delay can you have within the process without delaying your overall timelines. And just one final point, this is also useful because it helps you as a project manager reallocate resources if needs be. For example, if you're running this particular process here and you're experiencing delays in your critical path, you know that you might be able to siphon off resources from step F or step E or step D. You can siphon off resources from here and reallocate them to your critical path so that your critical path remains intact. And as long as the delay in step F is less than 6 days, your timelines are fine. So it gives you a sense of how much flexibility you have in your ability to reallocate resources. So there you go, slack.